About to start in 30 minutes. No, 30 seconds. 30 seconds. So please grab your seat. We are about to start. I should go home. Just exhausted.
Okay, we start the next session. Please go to the seat. Okay, so welcome to the next session. My name is Harald, and I have the honor to leading this session. This is a really short session, 7 presentations, only 3 minutes. So when you have a question, it could be asked during the lunch later. And now we start with the first speaker, with Amor. So.
Okay, thank you. So I talked yesterday about a project where we translated 15 New Zealand codes into a computable form. That took us about a day per page of codes to do. So 2 experts independently translating English language into a computable form and then resolving the differences between those experts to have a good version of that. So like many countries, there are about 600 codes and standards which are applicable to construction and need to be checked. And so, as you can imagine, a day per page, that's a hell of a lot of work. 40 person years to do the codes and standards in New Zealand. By the time you've done that, they'll all have changed and you have to go back and do it again. So how do we do it otherwise? And so Stefan, the PhD student who's doing this work, is looking at how can we use NLP, natural language processing, as a way of being able to achieve that. So looking at different research questions, so how can we translate the regulations into a formal representation automatically? Can they be made scalable to the different types of regulations, prescriptive, performance-based, all of the different types that we have? And how can we ensure the quality of those translations when we have them? And the work that Stefan has been doing has been looking at transformer-based translations, natural language processing AI techniques to do that. There's not enough data to be able to learn from that. So I've been looking at how do we generate synthetic data so that we have more training data, and does that make a difference? Well, no, it doesn't actually make a huge difference to the performance of the system. Looking at the data quality, so for the training data, the different people who are working on it encode things in different ways, as we know with classification systems, that people classify things differently. So if we harmonize those more, does that make a difference? Well, yes, but again, not as much difference as you'd expect when you have perfect data there. We looked at intermediate representations. So if you have an XML-based representation, trying to go directly from English to XML, that's a big step. Can we have an intermediate way of representing the regulations? And yes, that does make a difference. So if we have a simpler form that we can then translate into XML, that seems to work. Can we look at large language models and so use a large language model to do a translation from English into this formal representation? Amazingly, that works. There's very little legal rule ML out there, but it can still do that translation and can do that translation pretty well. And then developing an editor that helps people take those translations and make sure, a human expert make sure that they are correct. That's my 3 minutes. Thank you.
Thank you very much for the presentation. The next speaker, please, Giancarlo de Marco.
Good morning, everyone. My name is Giancarlo de Marco. I work at Fraunhofer Italia, and my presentation shall be out. Maybe? Okay. What I'm presenting today actually is an evaluation whether or not IDS can be used in the process of digital building permit. IDS, of course, as you know, is a sort of brand new standard, not fully yet released. And well, of course, we started from highlighting which are the limits of the traditional building permit in efficiency in data management. I mean, paper-based process can be very tedious to manage, as we've seen in a many presentation yesterday and also before. It implies limited scalability for growing projects and, of course, is a barrier to integration. How IDS can enter the digital building permit workflow. Well, this workflow you see here is, of course, taken and expanded from the one available on Building Star and Building Smart International, and it includes the IDS as something that is produced from the public authority or the appointing party, and what is the actual benefit that it can lead. Of course, it leads to a standardization because you take some requirements and you transform them into a machine-readable format that then can be used, of course, to check the model and sometimes even before help the designer to pre-check the model before the submission. And of course, the adaptability, because the idea is that you can still modify the IDS. It's very easy to write and it's also very easy to check. What we achieved in this first study, well, some easy checks can be conducted with not much effort, and I see that we sort of prepared or explored some ways for public authorities to adopt IDS in their workflows. Among the different tests that we conducted, the management of these checks leads better results with the help of the entity facets, one of the 6 available for the standards, and of course it implied a reduced workload for the digital building permit validation. Still, this is not the end. Of course, the standard is not fully yet released. There are plenty of things that can be improved. And the standard itself has some limits. I mean, it is hard to express complex requirements in this standard. Maybe some achievements can be obtained from using another of the facets, the part of, as it implies the study and the leveraging of the relations between the entities in the schema. Of course, geometric and dynamic conditions are out of the scope of this standard, so whether or not it's going to be easy, but or it changes. I mean, it implies that maybe this standard will have a broader approach, including some geometric conditions, or we actually manage very, very carefully how to put the information inside the model. Of course, one of the limits is also that the rigidity of data structures, once we build and create these data structures, there's not yet an automated way to update them, so it has to be redone sort of manually. So these are my contacts if you want to speak more about the IDS, and thanks for your attention.
Thanks. The next speaker, Judith Fauth.
Hello again, everyone. I think you have seen me around, but I didn't want to miss to give you or to show you a little bit about my new research project. I just started in January at the university at Cambridge, or of Cambridge actually. So it's a concept for leveraging road digital twins for enhanced planning and building permit processes. And as you know me, I'm just doing research just about building and planning permits. So what is she doing now with roads and road digital twins? So it's rather simple. So I assume, and this little bird does not belong there, but so we have road and road digital twins, and we have cities and buildings where we need permits for. And the road and the road digital twins may have information already stored, which we can use for one or the other. So the objective is more or less to linking road digital twins with building permits and planning permits. We use the information, breaking down the information silos, and to leverage the connection between both. So this came up with a lot of research questions. I just want to highlight a few. So, for example, the first block is more about decision making. So, can we enhance decision making if we are using other domains for permitting? And how does it might affect the quality and quantity of building permitting and the decision making within that? The second block, it's then more about the components and even how can we create a business model for that. But also, can road digital twin-based building permitting increase certainty somehow in the construction activities? So this is the concept, and this is also the last slide. So I would start with work package 1, which is on the bottom of the slide, with some information packages where I need to define what do I need, what kind of information I actually need, and how do they match. But it's not just about what, it's also about when and who. So at what phase of the process do I need that kind of information, and which stakeholder is involved in that phase. After I have collected that, probably it's the most time-consuming part, I also have to do something about knowledge management, uncertainty, and business cases. And if you are, I think you are yet now very curious about how such information packages look like. So because I'm running out of time, you can read through them. And if you are interested in, please contact me. Thank you.
Thank you. Next speaker, Stefanie Kaiser. Here.
All right, it's working, right? Yes. Good morning, everyone. I'm Stefanie Kaiser, and today I'm here to discuss the urgent need for sustainable practices in construction industry, a sector that significantly impacts resource depletion, waste generation, and energy consumption. By 2030, buildings are projected to emit a substantial amount of CO2 emissions globally. And to address this, the United Nations comes up with 17 Sustainable Development Goals, focusing on Goal 11 on sustainable cities. Digital building permits comes up with a solution replacing the traditional paper-based methods with efficient online systems. However, there is still a gap in understanding the link between DBP, sustainability, and BIM, which our study addresses using a Venn diagram. We have identified the key characteristics of each individual concept. Starting with sustainability is guided by long-term environmental considerations, often supported by standards. Digital building permits stand out for their automated code compliance checks, while BIM serves as a collaborative tool in integrating the project data, including parametric modeling techniques. The overlap between BIM-enabled DBPs enhances accuracy, coordination among stakeholders, automate code compliance checks, improving collaborative efficiency. Digital building permits, the overlap between digital building permits and sustainability enhances operational efficiency, streamlining the outcome of environmental consciousness, and serves as one a solution for reducing carbon emissions, aligning efforts to unify sustainable regulations, implementing energy efficient standards. The overlap between BIM and sustainability implements resource efficient sustainable practices, considering sustainable aspects during the design phase. Integrating sustainability into BIM-enabled DBPs improves the quality of built environment, achieving sustainability goals while meeting regulatory requirements, and finally is a guide for sustainable decision-making in DBP processes. In conclusion, our study needs to integrate the sustainability BIM and DBP for a sustainable urban development, and paves the way for a future research in energy-centric approaches alongside case studies in Germany, Denmark, and Romania. Thank you very much.
Thanks. The next speaker, Pablo.
I am Pablo Vicente from the Building Digital Twin Association. What I'm going to describe today is results from one European project, DigiChecks, about the privacy problem in building permits. Of course, we were using process diagrams in a different approach, perhaps, than other partners in this problem. But the idea is that we were using process diagrams and simulation on the process diagrams. We use as a base the description, the legal description of process in Madrid, because it was a very updated regulation. So based on the regulation, we identified like 85 basic processes. From those 85 basic processes, we derive 21 processes, like this one here. And with these 21 processes, we perform a lot of simulations. The idea is that as soon as you prepare a protocol for privacy, you should be able to check what is the impact on the process if you apply the protocol. But where is privacy in construction and building permits? This is an example of Seville in Spain, where this nice monument, when it was finished, people realized that thousands of people were just in front of the window of one of the neighbors in Seville, which is a situation not comfortable for that neighbor. There would be architectural privacy, but we find privacy problems when we manage documents and we are storing or passing or auditing documents, because it is true that when the building is designed, nobody is living there, but 6 months later, there's a human living there, and no one wants the information of his house to be in a portal or somewhere. Well, we were basing with the discussion in this BAN approach. This is from Brisse in Austria. And the idea is that if you want to perform some privacy checks, you need to consider the surrounding of the building and some characteristics of the spaces as well. These are the metrics implemented. This is a tool where you are selecting which category and which item you have. So you can derive a scope, an evaluation, a numerical evaluation. And this is the impact in one of the processes about the privacy check. So we can see the increase in the project presentation process, I think, the impact on the protocol in that process. And this is a risk analysis in the same report that you can read. And if there is any doubt or contribution, you can contact me, because this privacy problem looks like nobody is interested in it. But it is interesting, important. That's all. Thank you.
Thanks. Next speaker is Sarah Kumai. Please give the microphone.
Hi everyone, I'm Sarah Kumai from University of Brescia. Today I tell you about our research. Please, next slide. Sorry. The building permit is required in order to construct a new building and is issued by the public authorities after verification of the design conformity at both building and city level. And in most municipalities, this check is manual, but with the increasing of adoption of the BIM in the building design processes, several municipalities are investigating in the semi-automation of this control. But to do it, it's necessary to prepare information models of the building and 3D models according to appropriate information requirement. The research aims is to extrapolation of BIM and GeoBIM information requirement from building regulation. The first step of the methodology is the identification of relevant building permit checks. We shared most frequently control with to the municipalities, and thanks to a direct comparison with them, it was possible to establish which control were performed by the municipalities and rather than by the external authorities. After that, the second step is the interpretation of the standard. We use the RIS methodology to identification the requirement, applicability, selection, and exception. And each element was detailed to identify data type, comparison operators, value, and the unit of measurement. This data was represented in the conceptual model using a unified modeling language, and this conceptual model were validated directly by the municipalities and expertises. After that, to identify the scalability, the flexibility of our research, comparison of results was made. This methodology was applied the first 4 set of control. The work led to the identification of the entities and their attributes that must be present in the model. And the normative analysis had to address and overcome the understanding concepts. There is a limitation of the potential scalability of results due to height diversity. And the future goal is to extend the analysis to a larger number of regulations. Thank you.
Thanks. Thank you. Now we start with the last speaker of the session, Petri Koko. So.
Thank you very much. Okay, this is the last one before the lunch, so let's do it easy way, not disturb brains too much. So some sample cases in Finland, how actually this system has been used. First of all, I come from the SOVA 3D, which is developing this Kunda 3D, a 3D collaboration publication platform developer of municipalities. And our first case was when we started the project in 2015, we integrated the system with the Lupapiste, which is the cloud permits Finnish version of this electronic permit system. And there's the view of how it is used nowadays in our client municipalities. But this background there, this GeoBIM, I could call it like a city model, is used in many use cases before and after as well, which is in this case you can see in planning 3D visualization. And here you can see the simulation of the 4D schedule of the construction zoning of the city model, and IFC models are intensively used there, and actually the IFC 4D features included, so you can demonstrate the progress and some other issues on it. And then you can also get the users involved by polling, commenting, and presenting users by their own suggestions for upcoming new development areas. And one use case is the presentation of architectural competitions, like this case from the city of Jyväskylä, and also different alternatives of the city model can be evaluated. And nowadays also the laser scanning and that kind of methods are more and more common. And for example, there's a case of the Destia, which is laser scanning 44,000 kilometers of roads of Finland, and they are importing them on a web browser to be sold for the municipalities for other use. And here you can see the infrastructure models, how they are used as well there. And some of the nice new things is that after the building has been completed, you can use it as a part of the metaverse as well, and use it on other domains like in tourism, museums, and so on. We have made some samples there. And that's about my presentation. And if there's still some time, you can try to connect to the system by yourself using this link there. Thanks.
Thank you very much. We will then move on actually to the next session. We are really agile today. I am Rita Lavikka from VTT, research team leader, for those that maybe slept a little bit later today. Welcome. We will have next a technological session. Of course, they put a process researcher to make sure that I make the silly questions. But we will be talking about semantics. So how do you enrich your data with meaning? But first, we will have a sponsor talk from Edward Loskos, representing the Building Digital Twin Association. And he kindly informed and warned me that he has too many slides, so I'm trying to be...
Yeah, I always do the same. Hello. So after so many months, it's really a pleasure to have you here in Barcelona. Okay, so I'm happy to see that finally it happened. Okay, so it's I'm gonna talk a little bit of who we are in the BDTA. Okay, so the BDTA we started we are a non-profit. Okay, and we founded the BDTA in 2020 with the COVID situation. It was not easy, but we achieved to did it. The vision and the mission is quite long, okay, but at the end what is clear is that we need to coordinate, okay, all the digital data streams that we have across buildings, okay, to reach an efficient decision taking, okay? And this should be linking all AECO, okay, it's architecture, engineering, construction, owner and operators, stakeholders across the building life cycle, okay? And that's our mission, okay? That's our guiding principles, which obviously the ethics are the second one. I think Pablo was talking about ethics. I think ethics in the digital twins is something that are crucial, but even more when we are talking about buildings, because we are always thinking on the buildings of other people, let's say, okay? But it could be the digital twins of our homes. So this is a lot of things that we have to consider in that. Okay, so our origins actually were the Sphere project. Okay, the Sphere project, it was one of the biggest, if not the biggest, of the energy efficient topics called, okay, the PPP. Inside of the Horizon 2020, it was a 48 months project. Okay, and I was the coordinator. Okay, since I'm also the R&D manager of IDP. Okay. And we were co-coordinating with BTT, okay? So the point is that we were discussing a lot of new things, okay? What is a digital twin, how we can do, should we use IFC, should we use other formats, how are we including the sensors of information, is just a 3D with some sensors connected, or is just a model of simulation? Okay, so we started to have a lot of discussions to reach some agreements inside of let's say a huge consortium, because we were more than 20 partners. Okay, so eventually we reached to the point that say, okay, we need to found, okay, this association so we can keep track of all this knowledge that we were generating at the time. Since when the European project will be finished, okay, all this will keep going, okay, so at the end, we were kind of pioneers talking about digital twins in the built environment. So, and this is why we created the VDTA with those things or those axes in mind. Okay, so obviously providing the methodology, the definitions, that the new roles that we were proposing. So through publications, even in the future, starting to help with trainings, open technologies, okay, and even bringing new potential technologies, like it might be, we were on Wednesday, okay, during the ontology workshop discussing about what could be the next steps, okay, that we may take forward to help software developers, okay, and finally information managers, okay, who are developing the data structures of the buildings, okay, during the design and afterwards. So, but the most important for me is to generate this building digital twin community that at the beginning we were really a few ones, okay, but it's true that it's growing a lot, okay, and I think it's really important to share with you all because you are so close, okay, when you are talking about digital building permits, there is a lot of synergies, and at the end is one of the key enablers, okay, of digital twins, okay, when the administration is requiring, okay, to have let's say a standardized or a common data structure, okay, that can help, okay, to keep track with all this information. So that's the working groups, okay. As I was mentioning on Wednesday, we met again the Open Technology Framework group, okay, so the ontologies as we call, or the semantics group, okay, but we have other groups that we are working on that. Let me just, okay, so mention about things that we have done, I think in the first group, which is the definitions of roles. You can just download our white paper, okay, it was, we published that in 2019, that now it seems like really far away, okay, but I think it's still very valid, okay, and it was not just an exercise done by the consortium of Sphere, okay, it was Ioannis Brilakis from University of Cambridge was helping, even Michael Greaves, okay, the person who invented the concept of digital twin from Universidad of Florida, okay, he was participating in the document, okay, so, and we were using, okay, we were reviewing the state of the art of digital twins at the time. What was the state of the art of digital twins in the built environment, which at the moment was just the UK DT Hub, okay, or the National Digital Twin in UK. Okay, I'm saying just, but it's a huge effort, okay, and something that we have been always looking at. And obviously reviewing the ISOs at the moment, that was the 19650. In any case, okay, you have all this information. We were even proposing new roles, okay, and this was also the basis of that we proposed to have a new creation of a new working group, okay, inside of the technical committee. Okay, we were accepted in 2020, early 2022, okay, and right now, okay, with this group, okay, I'm the convener of this group, and we are about to publish our first document. It's just a technical report, but I think it's a really important one, okay, where we were gathering more than 37 accepted case studies. Keep in mind that since we do not have proper definitions in place, we did not, let's say, classify, okay? We tried just to accept, okay, if they were in the correct format, okay, using the template we provide, okay, and try to classify, okay, in the different benefits that those, let's say, digital twins. Keep in mind that we were from bridges to train stations to residential houses, hospitals, even our irrigation system, okay, or so I think it's a really interesting thing, because at the end we saw that the benefits were, I think, pretty they make a lot of sense, okay, but the most important thing for me is that we were not just focusing on one benefits, okay. More than 70% of the use cases received, okay, had more than one purpose in mind, okay. So, and I think that's really key, okay, so to look for synergies. So we are obviously working on liaisons with other groups, okay, and working in the ontology, okay. So as I was mentioning, okay, that's we have already published material on that regard, okay. And based on the objectives and the roadmap, okay, we expect to produce a catalog, okay, for during 2024 that could help, okay, to link, okay, ontologies, okay, and to produce, okay, actually this is a review of the white paper 3 we produced in 2022, okay, where we were analyzing, for example, Deacon, okay, which is also a repository for ontologies. Okay, in terms of simulation, we are proposing new concepts. We have new European projects, so we are putting a lot of effort on that. Okay, and I think it's also there are material, okay, that you can download, okay, and you can take a look to see how simulation is going to help, okay, to get better buildings in the future, and how we think that could be included into the methodology of the digital twins. So that's our congress. Okay, we set the fourth actually on Wednesday. Okay, so as forming as part of the digital building permits. Okay, this time we went back to Barcelona, okay, and somehow we achieved to get also digital building permits here, okay, so thank you for coming to Barcelona. Okay, at the end, that's the things that have been evolving, okay, and you know, okay, so we were here, okay, with the digital building permits, okay, and that's the sessions you will be able to see it, okay, so we were focusing on the use case of receipt and also in interoperability and see how we can link with the Green Deal. So I think there was a lot of slides, probably too many information, but you can go to everything is open, okay? And just saying that if you want to be part of our community, we will be glad to make this bigger, okay, and to make this happen. Thank you.
Perfect. Thank you so much. And you will be here for any contacts and comments. Yes. Okay, perfect. Then we will have our first research presentation in this track. So please welcome Tanja Bloch, talking about semantic enrichment of BIM models.
Yes, hello again. Can you hear me? Yeah. All right, so I'm happy to continue the session with a talk about automated code checking. Specifically, I will present a test case where we used graph neural networks to enrich BIM models with regulatory concepts to support ACC. So I think I can pretty much skip this because all of you are already aware of the problems and the challenges that we have in automated code checking. We have the regulations on one hand and the need to represent those in computer-readable representations. On the other hand, we also have the design that also has to be brought into computer-readable form. Eventually, we need to be able to compare between the two. This is the essence of doing code checking. And here we can see that many times there are concepts within the regulations that are simply not explicitly described in the design. And sometimes they're just concepts that the way that they're represented in the regulations simply does not match to the way that we see them in a design. So eventually we end up doing this matching of concepts, which requires a lot of human understanding of both sides and leads to quite a lot of manual work. So the goal of this research was to see if we can automatically infer and embed BIM models with regulatory concepts so that we try to increase, to reduce the amount of manual work in the process, but also maybe increase the capabilities of these workflows by enlarging the scope of regulations that we can check automatically. The test case that we chose to do this comes from the Israeli regulations for security rooms. So these are bomb shelters, essentially. Unfortunately, we live in a very complicated environment, as you all know. There are lots of regulations and guidelines as to how to design and construct these security rooms. One of them is that they have to be stacked one on top of each other and create the security shaft, and that the walls of that shaft have to be continuous and reach the structural foundations. And if you think about it, one of the problems is that when you are talking about a residential building, many times in the lower levels you will find parking lots. You will find storage facilities, different public areas, and so on. And these walls are simply in the way. So the designers don't like this. They don't want these walls there. They're trying to get rid of them. And the regulations do allow it to some extent. So the preferred situation is that when you look at any space that falls within the security shaft, at least 70% of the walls that surround that space have to continue and reach the foundations. But you can also have between 50 and 70%, and you can even have less than 50%, assuming that you then comply to a long, long list of other requirements. So this ratio of supporting walls actually dictates the requirements for the thickness of the structural elements on the lower levels, and this is the focus of our check. As for the calculation itself, so this is very, very complicated. One of the problems is that we do have many guidelines as to how to calculate this ratio of supporting walls, but we also have many, many, many exceptions. So, for example, if I have a wall with an opening in it, sometimes it will be counted inside this ratio of supporting walls, but sometimes it will not. It depends on the configurations of the walls on the same level. It depends on the sizes of the openings. It depends on the distance between the openings, but also on the relationships to the other openings in the walls on the same level. So the way that we have decided, what's more interesting, by the way, is that we don't really care about the number. It doesn't really matter if it's 70% or 75 or 85. All we need to know for each space within the security shaft, which of the three classes that I see here on the right side do these spaces belong to. So we are treating this in a completely different manner. Instead of actually doing the calculation, we are doing it as a classification task. And for this classification task, we have chosen to implement graph neural networks, GNNs. So GNNs are basically machine learning models, but they operate directly on graph. And the reason that we chose to do this is because there are so many relational aspects and relational considerations and guidelines within the regulations. We had to somehow find a way to express that within the machine learning model, and topology graphs are actually perfect to do that. This is probably new to, it's not new to anyone. Every time you're doing something with machine learning, you always have a problem of data for training. So we had it as well. We had to generate our own data set for training, a synthetic one. And we had to do it while really trying to mimic the real world as closely as possible, because the idea is then to take these GNN models and to apply them to check actual real models. So we had some help from one of the building control companies in Israel to guide us through the possible design variations. We ended up with 710 beam models of security shafts. These were then translated automatically into the graph representations when we have spaces, walls, and openings as nodes on the graph. And we have both the horizontal connections between the elements and the vertical ones as edges. Come to the training. So we have trained several different GNN models, obviously played around with many different model architectures. You can see that the one that performs best in this case is the Graph Attention Network, GATT. We got to 94% accuracy on a test case, a test set that is a portion of our synthetic data set. The reason that you see 4 classes here instead of the 3 is because these models are doing node classification. And since we also have openings that are represented as nodes on the graph, they are being classified as well. So we had to introduce this not applicable 4th class to be able to deal with those. But of course, we also tried different graph structures. So for example, we have a graph structure where only spaces and walls are represented as nodes, and then the openings are features assigned to these nodes. So you can see that there's some difference in the accuracies of training, but not that significant. Final stage of this was to actually implement it to check a real beam model. So this is a model of a residential building with 13 floors and additional 2 underground parking levels. We have 5 security shafts here. The first stage was to actually implement the GNNs to classify all the spaces within all the 5 shafts. What happens next, once we have this classification, it inactivates the proper rule set for checking the requirements for the thickness of the structural elements on the lower levels. And you can see that out of 265 walls and slabs that were eventually checked, we only got 27 false positives. So these are elements that are compliant to the code, but they were wrongly tagged as not compliant. What's more important is that we got 0 false positives, negatives. But we cannot conclude that these would be the accuracies for all other scenarios, for all other problems, because this is machine learning. It's not deterministic. We cannot guarantee the accuracies that we obtained at this point. We'll be able to replicate them, but I think there is still much work to be done to bring those machine learning models to a place where they are reliable enough to use in ACC, beginning with dealing with datasets, expanding datasets, because 710 models is not enough, constant checking, constant validation, and constant improvement of the models themselves. But I think that the most important conclusion here is that we don't have to confine the entire checking process to rules. There is a space, I think, to think about scenarios where more flexible solutions can be more helpful, even though they are not deterministic. And maybe we can think about some kind of hybrid approaches and human-in-the-loop processes that together will lead us to a place where we have very accurate results eventually. That's it from me. Obviously, there are lots of details that I did not mention. Please feel free to contact us if you are interested.
Thank you. Thank you very much. Any questions? We have room for one. Yes, please.
Thank you, Tanya. So a very interesting approach. I was just wondering for those that are not accurate, that the walls, 25 walls or something you mentioned, how long do you think for human to correct them? Because, you know, for a machine learning model, you don't know which walls are incorrect. You just know the numbers.
So the result in this case is telling you where the problem is and what the problem is. So you'll get an answer of this and this wall is, I don't know, 20 centimeters thick, but it's supposed to be 50 centimeters. So then correcting is really not a problem.
You're okay. Okay, thank you so much. And you will be also here for further discussions. But then let's move on to the next one, Gonçalo Costa. I'm so happy. Remember to mention Accord project.
Okay. I think it's in everything, so you can follow. This is your microphone or my one? I have two. You can use it? Okay. In stereo. Okay, good morning. My name is Gonçalo Costa. I'm from La Salle University. I'm from here. I'm local, from Barcelona. So I am going to present something that we did as a part of the development of the Accord project that has to do with formalization. Formalization what? Formalization, how we can formalize the regulations in PDF to knowledge graphs. So in this contribution in this project, there was several authors that participated in this work. So let's start with the typical slide that in all the presentations normally appear in the first plane. Okay, we have building codes and regulations, then we have complex language and technical vocabularies, and then this leads to a difficulty in interpretation and their application when we think in terms of automation. How we can automate things that are defined in different languages, in different vocabularies, technical vocabularies. Then, in a second line, we have BIM, we have digital tools, okay? This is supposed to help us to provide this automation, fine. But I want to stop here. We saw in all these presentations that we have different tools that try to solve the problem in different ways, but in the end, what we are saying is, okay, this tool is for this municipality, or this tool is for this country, or this region. But at the same time, and I think that we saw in the presentations from Peter and from Tanya this morning, there are different processes with different people, different regulations, different ways of writing the regulations, different many things, cultural things. So probably it's difficult to think that someday will someone create this final tool that will solve all the problems at the same time. So instead of that, maybe we have to think about an ecosystem. An ecosystem where we have different components, and one of the components maybe is one of them that we want to present now, that is about how we can provide the first step. Let's say we have building codes and regulations. We can transform these building codes and regulations in something that has be machine-readable. So maybe the question is how we can help to provide this automation, not to try to solve all the problem, all the approach. So that's our proposal. We have these PDF regulations that we want to provide in a machine-readable format. So maybe here there is a parallelism with the open BIM and closed BIM. So maybe we can talk about open regulation formats and closed regulation formats. And this ecosystem, we're proposing this solution as a part of the open regulation format. So what's the idea here? The idea is not provide a machine-readable for one specific tool, is provide a machine-readable that can be reused by many tools. Tools or some people that have the knowledge how to develop these tools for their specific use case. Because maybe there be a lot of infinite use case around the world with all the municipalities, administrations, and blah, blah, blah. Okay, so how we can do it? We think in three components, basic components, to provide this machine-readable format. First thing is, okay, we have the regulations. Maybe we can provide a way to represent this knowledge about the regulations in an ontology. So the ontology is providing a way that defines all this knowledge in a way that then someone can understand how it is represented. So the first component is the ontology, something that we develop as a part of the project. And then also we need a method to lead the user, because in the end, we agree that we need a user that take this regulation and convert this regulation in something that can be represented under this ontology. So we choose as a method, the race method, but this is an approach. So if tomorrow there is a better way, a better method to make this transformation, this can be changed. And the approach is valid again. So we don't change our approach in this. So we are choosing this method, but we can change this method if there is a better one. And finally, to define in the bottom of this kind of data structure, because in the end, when we are talking a machine-readable format, we are talking about documents that are described under data structure. So in the end, we need these mathematical way definitions, like when we say, okay, this wall has to be have a width that have be less or more than 10 meters, for example. These kind of things. We create a language that is called BCRL, that means Building Compliance Rule Checking, where in the bottom of all this ontology, we are providing these comparisons or these formulas in this language. So a machine can read this and can apply automatically, or this is the idea. So to apply this approach, we are thinking in two ways. One way is, okay, we can automate this process. We try to automate how this formalization using the race method can be automated following NLP process. So this is one of the options. And the other is, okay, let's the user to make this applying of the race method, tagging, and then also defining the part of the visceral definitions. In the end of the process, we will have something that probably will require also these kind of links between, if, for example, if we're thinking that this have to be checked in a BIM model that is defined in IFC format, probably we will have these mappings to these kind of terminologies that will help to interpret these knowledge graphs. So this is the basic idea. We did some experiments with the Finnish regulation. This is how the race method looks like. I am pretty sure that most of you know about race, so are familiar with the results in HTML format. And here is the final step when we have this knowledge graph, in this case, in the YAML format. But this information can also be represented in other formats like JSON linked data or RDF, etc. The important thing is, in the end, we have a knowledge graph. Okay? Something that the people that know exactly how they have to apply the regulations for a specific use case will be able to apply it. So, results, we are in this point of the project, we are doing this generation of these documents. We have different pilot case. These pilot cases are in different languages, obviously, because we have different countries. But for make the things simple, right now we are translating all the regulations in English to make this process more simple. Then when we are sure that the process is working well, then the final stage will be try to, okay, now we have a regulation in Spanish or in French or in Italian, how we can make the process working in the same way. So this is our point right now. We are in the middle of the project. So as a conclusions, we can say, and next steps, we can say that semantic web and NLP process was a good approach to provide these outputs. And we are thinking now in providing this capacity to define the process to the end user. So we are developing a tool to let the user, the expert in the race, and also expert in municipality regulations, how to perform this process in the manual way. And we hope that have finished in the coming months all this work. And I think that this is all for my side. Thank you.
Okay. Thank you so much, Gonzalo, in time. Thank you. Now I saw so many taking pictures that I'm expecting a lot of questions.
Hi, Gonzalo. Thank you for your presentation. First of all, we are from Madrid, we are thinking in a new master plan, and we think of the regulations for the new master plan as a bunch of rules written machine-readable. So in the case you showed in your presentation, I think you consider the way of, instead of using natural language processing, you can apply these rules from a database or a graph model to the regulations. Mm-hmm. And, that's right. And that's the one question, and the other question is in the same way. For example, we are going to a new model of rules but some rules apply from the state or from the community. So it can be a mixed joint between natural language processing and database. Thank you for your answer.
Well, I don't go in detail in this part, but when we are saying that we are providing this natural language processing, the logical thing is say, okay, the natural language processing will provide the results, but then the end user have to be sure that these results are good. So the final decision will be on the user that say, okay, but maybe, I don't know, I am not the one that contributed to this natural language processing. It was the Birmingham University. We have a leader here. We can ask she any doubts, but if you want to answer, okay. Maybe we'll require another hour to explain this process in detail, but that's the idea, basically.
Okay, one quick question.
Do you think it is feasible to ask municipalities to adapt somehow a little bit their urban plans to do this processing of them, to translate them to some machine-readable format?
The quick answer is no. But if you are doing this, it's because we are thinking that it's possible. So the thing is that we have distinguished among these big cities and the small cities. Probably the big cities have more resources and more capacity to adapt to these kind of methods, but we think that small cities or small towns maybe have they are running out of resources, so it's more difficult to say, okay, you have to apply this method if you don't know even what is a BIM model. So we have to deal with this, but we are agreeing, I think that we can agree that this is a future, so they will have to adapt in some way or another, and this is, I think, is a good one.
Maybe there is business for some consultant company. Let's see. Thank you so much, Gonzalez. And then I would like to warmly welcome Laura Gonzalez. So experiences from Montevideo, so really far away. Welcome.
Well, thank you, Rita, for the presentation. Well, my name is Laura Gonzalez. I'm an associate professor at the University of the Republic in Uruguay. And well, today I am going to present this work, which mainly focuses on extensibility in the context of a platform that we propose for the digital building permit in Montevideo. This work is a joint work between the university, Pixis, which is a software company in Uruguay, Deac, which is a construction company in Uruguay, and the municipality of Montevideo. We have three of the members of the team in the audience, Raquel Sosa Bruno Rienzi from the university and Analia Semblan from Pixis. Well, first I'm going to provide some context about this project. In Uruguay, we have a program of innovation in public services, and the municipality of Montevideo proposed a challenge in this program, which basically it's I need solution that enables the automatic verification of the building permit in Montevideo. The scope of the challenge was a part of Montevideo was these 4 blocks in a central area of Montevideo and for new residential buildings. So in this context, the university, Pixis and Deac joined forces to conform an interdisciplinary team. We comprise architects, civil engineering, software engineering, and being expert. And we worked from around 9 months, and we developed such solution. And our main result were a life cycle for the compliance management in this context, and a platform supporting this life cycle. We have some guiding principles for our solution. Here we are going only to focus on extensibility within the platform that we propose. If you have more information about the whole work, at the bottom of the slide, you can find another publication with the whole work. Well, extensibility. We are going to focus on extensibility, but what do we mean by extensibility? In general, extensibility of a software solution is the possibility to add features, new capacities, capabilities to the software system without the need to update or to modify the core of the system. We believe that for DBP solutions, this is a relevant quality attribute because, for instance, we can extend this solution to apply to another geographic location, to another type of buildings, to another building permit requirements, or to include other compliance mechanisms. In this work, we focused on how to extend our solution with new building requirements and with compliance mechanisms. So, before getting into the extensibility, I'm going to explain a little bit how our platform works. The main idea is that applicants work in a modeling tool, modeling the building. Then they have to export this building to an IFC file. They have to upload the IFC file to the platform. The platform performs some checks, but if everything is okay, the file is stored in a file server. And then the core of the system performs some tasks in order to return an answer to the applicant. If some requirements were not met, the platform generates a VCF file, the Avin collaboration format file. And the idea here is that the applicant can import this file to the modeling tool, so he can or she can see the problems in the context of the modeling tool. But how the core can do all this stuff? Well, it relies on many components, in particular a repository of digitalized and executable requirement. Here we use the standard decision model annotation, which enables to specify requirement or rules, and at the same time provide an executable format. So for each requirement or for each rule, we need to specify and deploy a BPMN decision. Then another important component are data providers. Here the idea of data providers is that they are responsible to obtain data from the models or from the environment in order to be able to verify the compliance with requirements. We categorize the data providers in data structure, which are able or know how to process IFC files. We also have data consumer. We know or specialize in how to interact with external systems. And we also, to complete the cycle, the platform needs to have information about the requirement. For instance, here we have the max height requirement, the decision which has the verification logic of this for this requirement, the data that this requirement needs to be verified, and the provider from which this data can be obtained. So at runtime, when a request to verify a requirement comes to the core knows from where to obtain this data, so send a request to the different data providers. The data providers answer with the values of this data. The data is stored in a database, and as soon as the platform gets all the information to verify a requirement, it invokes the BPMN server with this data, and and at the end, the core can respond to the applicant. Okay, so this is more or less how the platform operates. So now we are going to see how or the level of extensibility we can achieve with this kind of architecture in three situations. first, in light blue, you have a new requirement that we want to add to our platform. In this case, this new requirement only needs data that another requirement already needed. So in this case, the only thing that we have to do is to specify the DMN decision with the verification logic for this requirement, because the other thing was already done for other requirements. Another case is that if we want to add a new requirement which need data that was not already needed for other requirement, in this case we have also to specify the verification logic in DMN, but we may need to extend an extractor or a consumer to be able to extract this data. And also in the database, within data database, we have some more information. The final case to analyze extensibility is when I want to add another data provider, for instance, to perform a specialized calculation, or another thing. So here also we have to specify the decision logic. We have to implement this data provider. In this case, we have another category, calculator, and we have to configure how to communicate with the data provider within the platform. Okay. And well, also we need the new data in the database. Well, with this architecture in mind, we implemented a prototype in Uruguay. In particular, we were able to specify 15 requirements applying to Montevideo. So we have 15 decisions specified in DMN. The idea is to be agnostic of the different tools or platforms. We try with Revit and with Blender in order to have two modeling tools. And we use different open source products for the different components in order to implement this prototype. So, as a conclusion, we confirm the technical feasibility of this proposal, of this architecture. We think that the result may be used by researchers or practitioners in the area. In future work, we would like to address other dimension of extensibility. For instance, if we can apply this in other locations or for other type of building, addressing and analyzing other quality attributes. When we, for instance, focus on extensibility, maybe performance becomes not so good. Well, in general, we also plan to continue advancing in the DBP area. So, well, thank you for your attention.
Thank you so much, Laura. Excellent example of using open source. There's already Odilo. You're the winner. Yes.
You get later the €20. Thanks. Simple question. Are you the first one in this conference to name DMN? Or you're the first one, isn't it? Did anyone else present DMN solution?
I think someone yesterday...
Because it's cool. It's really good that you name it. That's the key.
It might be the only... Okay, really quick. Yes.
Okay. There is a problem with DMN that it doesn't handle unknowns. How do you protect the rule engine from information that's not available?
What is the problem? Sorry, with DMN?
DMN can't handle unknown values.
Unknown values. Okay. We performed a first pilot, so we didn't stress DMN. So maybe we can talk later and you can tell us about it. We only modeled a 15 requirement, and they were like some simple one, but we didn't stress it to find the limitation. So.
Excellent suggestion to work on it during the lunch.
Yeah.
Thank you so much, Laura. Yeah. Yes, and now we still have 2 presentations to go. So from Montevideo to Berlin. So please welcome Konstantin Schneider and Kai-Uwe Krause.
Is it okay? Okay. Hi, so my name is Konstantin Schneider. I'm currently working at Tegel Project, which is the organization that is organizing the renovation of the former airport Berlin TXL. And next to me is Kai-Uwe Krause. He is the leader of X-Leitstelle, which is an organization for semantic standardization in Hamburg. Today we're going to tell you something about the German use cases of the Accord project. Maybe you heard about it because it's supported, the DBP, by this. And also listen to Rita. And we focus on the German use cases and the German demonstrator. Okay, maybe we start with the partners. First we have the Fraunhofer Institute of Building Physics in person of Katja Breitenfelder, and they are coordinating it and leading the whole German demonstrator. Then we have, as I mentioned, X-Leitstelle, led by Kai-Uwe, which has a really complicit name in English. It's the Coordination Office for Semantic Standardization in Planning, in brackets, X-Planung, and Building for Public Services. So they're going to provide us the knowledge about semantic planning law and also bringing it to practice. Then we have the OGC that are supporting us with developments of new standards. We have Ontotext that are helping us with the conversion to the RDF representation, which Kai-Uwe will refer later on. And last but hopefully not least, Tegel project, which is the location of the project and providing the data and the requirements for all three use cases. Okay, so we have three higher level goals. And the first is automatic compliance checking, as the Accord project as itself is the acronym for. So we want to check the BIM models against requirements that have arisen from building regulations in Germany, and also want to increase the efficiency and cooperation while the process. So we are not only focusing on the models, but also focusing on the processes, which is a special thing. So we got the second high-level goal. This is digitalization and standardization. We want to make the German build permits and regulations digital and formalize the checking rules for them. And also we are aiming to get an improvement and then progress in the standardization for automated BIM-based building permits, and also the interoperability of software solutions. And the last goal is the combination of sustainability and smart cities. And here is the elementary part that we use the urban and building digital twins. Okay, I think I have a little bit to hurry up. So we have three use cases. So the second one just is about the life cycle assessment. So we want to check the models against the regulations of the German Sustainable Building Council, DNGB, Deutsche Gesellschaft für nachhaltiges Bauen, just in case somebody knows. And hopefully Tegel will, after this project, Tegel will get a good score in this, and then maybe get a good certificate. We will see, but we hope this. So the third one is had some changes, and now is in the yellowish part on the right side of the Tegel area, the Schumacher Quartier, where we want to build 5,000 sustainable timber constructed residential units for 10,000 inhabitants. And we want to check the timber construction regulations on this, but the main focus is, of course, on the first, which Kai-Uwe will take on, planned land use permitting. And here you see the picture of how we imagined it. So it's formally the first place of arrival when you just came to the former airport. And it will be completely renovated and get a new use in coordination with the conservation authority. So if you want to do changes, you will completely need a land use plan which contains textual and graphic information. So the main question is how we can convert this to the semantic plan loading data. And the specific aim for this use case is that we want to create digital and linked database development plans with the use of X-Planung and the Inspire PLU. And now I hand over to Kai-Uwe. He will provide us some information about Xplanung, Xplan GML, and OGC API for futures.
Yes, thank you very much for your introduction. What's the next slide? So you can see on the right-hand side, you can see the legal binding land use plan for the Schumacher quarter. As my profession as an urban planner, I love these plans because these maps or these plans, and the more complex, the better it is. The better it is, and the question is how to deal with this complex information to store it in the machine-readable way. So, many of these regulations have to be checked as part of the planning permission processes, and they are stored in a graphical way as well as a textual way, and some of them are you've got to take in account to hold both, as well as textual regulation as cartographic information. And I doubt that the use of the race method for the interpretation of regulation in the development plans is scalable. We heard a lot of in the last presentations about the race method, but these plans, they are local laws and they are individual. And do you have an impression how much local plans we have in Germany? Maybe do you have an ideas how much might it be? We don't know it. We just think we thought about 400,000. Now we are think about 1 million. So 1 million plans you have to take in account for planning approvals. And now the question is, yes, how to represent this information in the machine-readable way. So and this is Xplanung is one goal or one and I use Xplanung and Xplan GML. Xplanung is the object model. It's in UML object model, and the data format is Xplan GML. It's an GML application format, but as well as we can represent the content of Xplanung as well in the JSON format, and it's possible to have a lossless exchange from one CID or BIM program, for example. This is AutoCAD representation from Xplanung. You can export it and you can import it, for example, in ArchiCAD, more or less lossless. This is the goal of Xplanung. And it is furthermore what we did it in our Accord project. We just design the legal land use plan, but we've got to extend it a little bit. The object model, according to the object model, it is possible to define relations, for example, between the zoning and elements and noise protection areas. But you've got to define this relation. So we extended it. We make it linked, the data capable, and we translated the German regulations in English. There's a national code list for all this German regulation. We extended and we imported in a Xplanung database and provide this data as OGC services or OGC feature services, and as well we did it for the Inspire plant list data model. Here's an example how we provide this data. It's an interface of our service. It's an open API for feature service. You've got access to data. All regulation have a unified URI, so you can access it worldwide. And of course, you can import it. It's in just an open source GIS or normal GIS system. And then one goal, but Vladimir, excuse me, will have lessons or a presentation on it. Only in short, we try to represent this information in a triple store image. And our goal is next to the land use plan, we also have to transform the IFC model as well in a triple store representation. This is one image of the representation of the X-band GML in RDF representation. And you've got you have an idea, maybe there is relations between the building areas and the textual regulation that are to be you have to check against on this special area. Our goal is now to enrich the data model as well as our planning, our legal land use plan. And then our goal is to define or to checking rules for the building use, the extent of the building utilization, the plot coverage ratio, floor space index, noise level. This is all. Yes, we've goal is to define some sparkle. Request on this triple store representation, so we can check against these checking rules. So the conclusion, it is possible to represent the complex textual and geographic information in spatial land use plan in a machine-readable way, and we can access this data with OGC services, and Vladimir will tell us more about then the transforming this data in RDF representation, and then we hope that we can define some sparkle requests, then we can approve our regulations. So that's all. I hope I was a little bit in time, more or less in time.
Thank you so much, both Stefanie and Kai-Uwe. Any quick questions? We have a really nice connection because Vladimir Alexiev will continue from this, so I suggest that we take that, and then maybe one question to all of you, if that's okay.
Okay, I have less than 10 minutes, but I still would like to ask you to make a quick survey. How many know a bit about knowledge graphs and semantic data? Okay, about 40%. How many of them think it's a good idea to use them in AECO? 10%. How many think it's a bad idea? Don't be shy. Okay, I can continue my talk then. I firmly believe in what it says here, that the world is connected, and I think semantic technologies, okay, they're a novel thing in many industries, but they really shine when you need to integrate data between industries. So On2Text is a Bulgarian software company. We've been working with these technologies for 24 years, and we are the semantic partner in Accord. But we work with many different industries, manufacturing, transport and logistics. Actually, life science is our strongest vertical. Okay, so within Accord, we're focusing on storing the regulations, which previously were described how they are RDFized, and also on land use cases, because planning data is not well represented in IFC. You can maybe twist IFC to capture it, but I don't think it's a good idea. It's also not representable in CityGML. In CityGML, you have real streets, real buildings, but you don't have planned land use. So one standard shown on the right is Inspire PLU. There's many others as well. So what's the difference between zones and parcels? Zones say what you can build, parcels say who owns it, and maybe what they have already built. Also, so here we're covering two cases, the German and also the Spanish case, or the Catalonia case of Malgrat de Mar. And over there, topography is also important because it's a mountainous terrain, just like Tibidabo here. And like, what's a basement? Well, on the back of the house, it's at a higher elevation. In the front of the house, it may be walk-in. So these kind of data models and their conversion to semantic data is something that we do quite often. Now, here's an example from the Spanish case. If you have a regulation that says cantilevered or balconies, they cannot overhang the street too much. How exactly you find what is a balcony? How do you find where the street is? How do you calculate distances? These things are not so easy. I won't talk about Tegel because this was already covered. I'll just say that the Tegel regulations are extremely, extremely detailed and specific, and the German way, okay? Maybe that's why builders still find it hard to go and build in Tegel. So here's an example from this LD proxy. By the way, these little blue things, we'll have a slide about it later on. This is an open story, so basically like a passage between buildings. And it's not very clear, does that belong to the one building or the other building, or is it a shared building part? And then how do you check it? Does one building fall into one planning zone? Normally you would expect that. And if it falls into several, how do you then collect all of the requirements from these zones, or is that a violation? There is also a very nice German classification called GD Germany. So this follows the Inspire POU classification of land use purposes, but it is more detailed. And also it's available in linked data. Those links, they're XML, RDF XML, blah, blah, blah. They give you not just the HTML page, but other machine-readable renditions of the data. And this is the essence of linked data principles. Everything should be identified by a URL. And if you resolve it and ask for the right format, you're going to get either human or machine-readable data. So here's a few examples from the German regulation regarding greenery. Not only that, they say part of the roof must be made nice for insects. You must have dead wood in whatever percentage. So here's this Luftgeschoss, and it took us with Hamburg maybe 2 sessions of 3 hours each to figure out what it means and how we can possibly check it. Now, for the Spanish case, there we need to check a cultural center on the left. It's a refurbishment project, and a new production plant on the right. And their regulations are split by the kind of site. So is it an isolated site like the plant, or is it seated between buildings and must align with the street grid and so on? There's detailed information, BIM, and the land use that is in the poem, cadastral zones, which are in GML, but not CityGML and not Inspire PLU, and also topography. What I don't like is that their land use classification is not very clean. So at the higher level, maybe it's okay, but at the bottom level, like, what is this last line? Tertiary industry, but more specifically the Bobila area. Okay, I don't know what that means. So the kind of checks that we'll need to do, I already mentioned maybe the more complicated check about cantilevered parts. We still do not have the information that binds zoning parameters to the zones. To say in this zone you can only build 30 meters high and 5 stories, but we'll find it out where it is. Now I turn to what standards are applicable in this case. Of course, IFC for the buildings, but then GeoSparkle, because we have a semantic database, so we want to use it to do the checking. GeoSparkle is the way to get geographic data in RDF. CTGML is quite important, okay, because if you have an IFC file, you face the difficult question, how do you georeference it? And what is which geographic coordinate system are you going to use? Most of the time you have to use an engineering survey system, northing, easting, not latitude, longitude. And with the OGC, we're going to be working on CTRDF. So there's already CTJSON rendition of CTGML, which is in XML. But RDF is what we need. Now, in land use, there's several relevant standards. I mentioned INSPIRE POU. INSPIRE is, of course, a very important European initiative on geographic data. And there are two classifications, HILUX and LUNOM. LUNOM is said to be the detailed one, but still it is not very detailed. In XPlan, they have quite more, together with this German classification, they have better nuances. So in addition to just saying park, you can say, yeah, but it's with child playing grounds or whatever. The way that regulations are attached to zones in XPlanung, which is positive because in INSPIRE POU you cannot do it. There's no standard format to say there's a text of a regulation and it applies. But in XPlanung they use some, let's say, textual notation properties to attach them. So here's an example of an XPlanung couple of classes and the properties. Okay, so why do we want to do this with semantic data integration? Because the three kinds of data that we have, regulations, land use, zoning, and BIM, they are quite complex, all of them. And if you need to use three different databases, for example, CT3D database and Revit and so on, it becomes very difficult to make queries between them, okay? Now, what is the status of all of these different standards? Well, JuicePark 1.1 came out recently, and it added some features to JuicePark 1.0 after 12 years. Now there's talk about JuicePark 2.0. I hope it won't be 15 years from now. What it lacks, however, is 3D geometry. So you can store Z and even M coordinates for linear referencing, but it doesn't do anything with them. And this, of course, limits the type of checks that we can do. Another thing is that from BIM, we have to explicate the geometries and store them in a simpler form. I mentioned that we are working on CTGML in RDF. Now, how do you convert an IFC file to something that is georeferenced and maybe CTGML, okay? Turns out that the question is far from settled. There's a bunch of tools, but each one of them has its pros and cons, defects, and so on. So we think the link building data community group, or maybe between the two projects, Czech and Accord, I hope to settle this question. Here's an example of a converter by Oraskari. So it gives you slices of the building and bounding boxes of floors and stuff. And it says this is in WKT geometry, but it misuses WKT. It uses millimeters, doesn't say what is the coordinate system, so it is not really compatible with the geo information. And I'm almost done. Here's a conversion script. This is a language called XParco. So it allows you to get data from XML, kind of like XQuery, and then to produce RDF. You already saw a bigger diagram of a regulation in the previous presentation, but this is how it looks. This is something called a turtle format. And that's it. We are, by the way, actively looking for partners because we cannot become experts in any vertical domain, but we're interested in many. For example, we're very strong in electricity. In electricity, there's the common information model, which is the foundation for the European single electricity market. So you can do electricity balancing operations across Europe and sell and trade and so on. And yeah, I hope to talk to some of the ICO companies here regarding partnerships. Thank you.
Thank you so much, Vladimir. That was a wealth of information, but I do get it. I have a nerdish husband, so yeah. I'm thinking about we are having the lunch. Should we say that discussions during the lunch? So Konstantin and Kai Uwe and Vladimir, you are still around here, isn't it so? Okay. Okay, then I will thank you warmly, all the presentations and all the active discussions from your side. Thank you so much and have a nice lunch.